All right, thank you very much. Let's begin. So my name is Alexander Rubin. I have been working with MySQL for a long time. I joined MySQL AB, company behind MySQL, and over years I got my interest in security. I started playing capture the flag games. And I joined Amazon Web Services about 2 years ago. And I'm currently leading what we called Relational Database as a Service Red Team. So we're doing the security research, and we're doing pen testing, and we are trying to attack our own services at AWS. And my colleague, Martin, he is here. He will be doing the second part of this presentation. Has been working as in database security space for more than 17 years, and joined the Red Team in 2022. And he has been doing penetration testing against various AWS services. So here's what we are going to demonstrate today. So in usual case, you hack a server, a MySQL server. In this case, MySQL server will hack you. So you connect to a rogue server and you get hacked. So we're going to demo that. But let me set up the stage for this. So let's imagine that you have a website, and this website was hacked. Let's say WordPress, Drupal, whatever. And a bad actor somehow getting a full access to the MySQL server. Now, you need to fix that. You need to upload, well, it is hacked, right? So you need to restore the dump. Restore the MySQL backup. So you or MySQL DBA connects to this database from its own workstation and gets hacked. So this is what we are going to demonstrate, and here's our agenda for today. Actually, to make sense of all of this, I will need to go through and talk about the MySQL server itself, the MySQL protocol, a little bit history of MySQL. And there was a bug that was actually fixed in 2019, silently fixed, no much information about that, that allows the remote code execution on the client side. And again, client side, it's pretty much your machine. On the client side via directory traversal. And recently in 2023, we found another twist to it. We found a bypass of the fix. And we're going to demonstrate. We reported it to Oracle, and Oracle just released this, created a CVE, and fixed that 3 days ago. Fixed that 3 days ago as part of the latest MySQL server and client. So let me start with the history of MySQL. So MySQL server, and first of all, is there anyone who have never used MySQL server? No one. So this is quite popular. So MySQL server has been actually created and released in 1996 by this guy, Monty Videnius. Right? He has created, and he named it after his daughter. The My is not necessarily mine, but the name of his daughter, My, or me, actually, in Swedish. And then Sun acquired the MySQL company, and then Oracle acquired Sun. So now Oracle owns MySQL. And Monty was not quite happy with that, and after Oracle announced that it will acquire Sun Microsystems and will acquire MySQL, Monty forked it and created MariaDB. So to fully understand how this exploit happened, we need to look at the MySQL architecture. So MySQL architecture has this flexibility in place. It allows you to have it allows a flexible, custom storage engines. And actually, we all know Monty, who is creator of MySQL and then MariaDB, but many people haven't heard about this guy, Heikki Turi. So Monty met Heikki at one of the conferences, and Heikki created a storage engine called InnoDB. At that point, MySQL was very simple. It didn't even have transactions. So Heikki created a transactional storage engine and transactional level for MySQL. And Monty adapted MySQL so that it will allow to have multiple different custom storage engines. So now you can create your own storage engine level. And you can have the storage level, but you can also have a pluggable authentication, AUF. You can create a plugin that will implement some AUF that is not available in MySQL via plugin. So this is the current list of different authentication. This is based on my MySQL enterprise version. But what those plugins are, they are just shared libraries. They're just files that is located in the so-called plugin dir. So a client has two parts. The plugin has two parts, right? So the plugin have a server part, and that is the file located on the server. But also plugin has a client part. It's located on the client. And you can create your own plugin, and you can distribute it, and then you can implement some additional auth method. For example, connecting to Kerberos or whatever. Kerberos is already there. But you can also create an open source versions of something that is not available in MySQL. So now there are usually a question about what's the difference. We have three major implementations of MySQL Server. It's MySQL community version by Oracle. Oracle also have enterprise version. Then there is a MariaDB, which is the version that Monty created. And there is Percona Server. They all pretty much share the old code. Some of the code dates back to 1982. It's still there in the MySQL Server, some functions there. And this is pretty much open source code, right? So MariaDB has been forked off the older MySQL version. All right, so you guys may be bored already. So let's go to the MySQL auth protocol. So I have created this oversimplified version of how MySQL perform the auth. So here we have client and server. Client is pretty much your workstation, or it can be a MySQL command line client running on the same server that the server itself, right? But in this particular case, I'm talking about the client being your workstation, a GUI tool or command line. So this is how the oversimplified protocol works. So your clients ask MySQL server to auth and says, hello, MySQL server, I need auth. I have username, and I have password, hash password, whatever. And also, I want to use the plugin. And I specify the plugin name, not the actual plugin code, but I specify the plugin name. right? In this case, I'm using MySQL native password, which is the default plugin. And the server says, okay, I have this MySQL native password. I actually loaded this plugin to be able to auth you. And I check the username and password using the code, the algorithm in this plugin, and I grant you access. Now, let's say that you have created your own version of auth plugin. And then you connect to MySQL again and says, hello, MySQL server. I have username and password, but now let's use whatever plugin that I have created. And the server says, well, wait a minute. I don't have this whatever plugin you're asking. But let's use another plugin that we both know. Plugin, again, is a language that both client and server speaks. So they're trying to communicate the language that they will be speaking. So the client will say, okay, I will load this another plugin name if I have it on the disk. Right? So what that really means is MySQL server can tell the client which plugin to load. And MySQL will try to load it. So what is the plugin? Plugin is a shared library. And what load means is that it's deal open on Linux or load library on Windows. So this is really interesting, right? So a server can tell client what to do, and the client will follow, will load whatever shared library it is told to load. So that opens lots of interesting possibilities, but let's look at the code. MySQL is an open source, and you can look and examine the code. This code is shared component. It's called SQL component, client plugin. So this client plugin is used when you compile the command line utilities or GUI tools. It's part of the server, but it's actually used for the client libraries. So client libraries are used based off lib MySQL. We'll use this code. So what this code is doing, it creates a string which contains the deal path, a path to the shared library. And then it will just do deal open. So this is pretty interesting. So this is the plugin name that comes from the server. This is the directory where the plugins are located on the client. And this will do just deal open. Right? So there are some protections. The plugins should be located in the plugin dir directory. And this plugin dir cannot be changed during the off phase. But we can do a directory traversal. So we can just specify whatever plugin name a client will be loading. So a server will push the name and the client will just load the plugin, the shared library. That's so easy, right? So that actually means that there's an arbitrary code execution via directory traversal. So that was actually found in 2019. So it's all started as HackerOne report against MariaDB. And there are lots of explanations there, what it can do, what it cannot do. And it's actually fixed. It was on June 12th, it was reported against MariaDB server. And then on August 2nd, it was fixed and released in MariaDB. So MariaDB did an input sanitization to prevent the directory traversal. Right? So it will check for all these symbols here. And this is actually good. A very simple, efficient path. So now, basically, we cannot do anything here, right? Because if we will try to push the plugin directory traversal, it will not work. And November 21st, 2019, fix was pushed to MySQL community. Oracle actually is very secretive about the bugs, security bugs. So it uses this non-public bug, but there is a commit, and there is a commit text here, which actually is very verbose and explains the issue in lots of details. Again, 2019 was fixed. So the fix is different from MariaDB implementation. In MariaDB implementation, it just checks for bad, symbols there that can be used. And here, it is a little bit more cryptic, right? So it uses this function called strcpn, and we will look at that function a little bit later. All right. So let's do the summary of this directory traversal. So all the MariaDB and MySQL versions are vulnerable. A server can push the full path, and client will load this whatever is being pushed from the server using DLOpen or load library. And malicious code can be executed as a part of init. What is interesting here is that it expects to load a MySQL plugin, right? But even if it's not a MySQL plugin, it will always load the init portion of that. So if we'll put a library which has the init in it, then we will be able to execute it. So that is fixed. Again, fixed in the MariaDB server versions and MySQL versions. So let's look at how it works, and I will do a demo for that as well. So again, MySQL client, it's your machine, connects to the server, and the server try to try to push the bad code in it. So what do we need to do to execute it? Right? So we need to have MySQL server. It actually can be any version. It just needs to support the protocol. We need to have the vulnerable version of MySQL client library. It can be a GUI tool, it can be a MySQL client, and stuff like that. And we need to have this MySQL DBA or whoever you connects to this server. So let's see how it works. A bad actor controls the server. The client is vulnerable. And we need to have the vulnerable code loaded to the client machine. So that sounds complicated, right? But let's see how it actually works. First of all, we need the ability to push the plugin name from the server. So there are two options here. We need to create some sort of rogue server or rogue auth client, auth server, right? So there are two ways how we can do that. We can either use MySQL server and create plugin. It's also called plugin. And another option will be to use the fake server written in Python. So what I did is, so let's start with this. So this is our plan of attack. First of all, we need to write this rogue server. Then we need to somehow make the client load that library. And then finally, we need to push the exploit code to your machine, to the DBA's machine. So let's start with the server. So I use this Python code, a fake server. I use the MySQL mimic code. So you can just install, like pip install MySQL mimic, and that's it. So then I do some overloading of the classes in Python. And what I'm doing here is I push the plugin name. So I configure my fake server to push the name of the plugin whenever a client will connect to it. And then I start in this main part of the script, I will start the server on the port that you specify. I specify, and I specify the path to the plugin. So that's pretty simple, and let's see how it works. So I start the server, I specify the directory traversal test, and I connect to this server. And then what happens is that it will reply that it cannot find the shared library file. That means that it's actually worked, right? It accepted the plugin name, it tried to do a deal open, and it failed to find that on disk. So again, this is an old MySQL client 8018 with an unfixed bug. So our injection worked. Now, what do we do with that? We either need to find the shared library to load, or we need to somehow push this exploit to the client machine. So we're here. We have written the Python script that acts as MySQL server. Now we need to have the ability to load arbitrary code, arbitrary shared library. So the problem is that this code. So first of all, we need to have the shared library, right? So it's actually super simple. I have created this super simple shared library constructor init, and inside of this init, I'm using system calls to do two things. First is I create a file on disk, and second, I open a calculator. Right? This is on Mac. So then I compile it with GCC, and then I have a shared library. Now we need to somehow be able to load that shared library code to the client. So it will be nice to be able to use an arbitrary file name. Currently, the code actually adds SO extension to that file name. And this is not good, right? If I somehow push this to the client, adding SO is more complicated. So let's look at this function. Actually, this function is, I was wrong. This function is 1984, not 82. All right, so we have the timestamp here. We have the author of that function. And this function is just copying the byte. But what is interesting is that it has a buffer overflow. It's not the buffer overflow we're usually working with. It actually do the length overflow. So we have this max length of path is defined in another place in the code, 512 bytes. And then we have this char DL path as defined of length plus 1. And then we prepare, we copy, and we basically create this DL path to concatenate the plugin dir, the name that comes from the server, and this SO extension. So if I supply from the server, if I supply a name with a number of slashes and make it 512 bytes, I will able to cut off the SO extension. So with that, I will be able to load an arbitrary file. So it's a sort of length overflow, right? So now, here is my demo again. I start the server, I supply this plugin name, and I also can see on the client side, I can see that it is calculating the size based on the plugin dir. So I will actually need to know what the plugin dir is. In this case, user local MySQL lib plugin. And it's a default setting, usually, especially on the old clients. Right? So now I created a Python function that generates the injection. So I need to supply the plugin dir to basically calculate the length properly. And then I have my traversal. And then I generate an injection string by adding slashes. On Linux, it doesn't matter how many slashes are there in the path. So then, instead of supplying the file now, I supply the injection string now. And here is another test. So I created the shared library, which will just create a file on disk. I compile the shared library and I copy it as a PNG file. Right? PNG file may be okay. It's not a shared library, right? Because of the extension. So now I start my rogue server, specify the file name. It generates this crazy path, and MySQL will actually execute it. It will give you an error because this is not a real plugin. I can make it real plugin, but I didn't even bother. And it created the file. So we can also verify with the strace. We can verify that this actually opens the PNG file as a shared library. All right. So now we have both the ability to push the plugin name and overflow this, cut off the SO extension, so we can load an arbitrary file as a shared library. So the final path is we need to push this exploit code to the DBA machines. And for this, we'll use some sort of social engineering. So then, basically, you can find a victim on LinkedIn and send a resume in a PDF file. And the victim will not, of course, will not need to execute or whatever, just needs to save it somewhere. On macOS, probably save it in home, whatever, documents. Right? So when you save it on disk, that's it. So I will do, let's see how much time we have. I will do the recorded demo, and then I will try to do a live demo, or maybe if we have time, I probably do both. Do you guys want live demo? Okay. All right, give me 1 second. Oh, here we go. All right. Hopefully it will work. So I have my virtual machine here. And this virtual machine is a server, a rogue server. So I have my rogue server Python script. Then I have my shared library. So in this example, and I will be opening a calculator, that's the goal. So in this example, Martin was kind enough to send me his resume. What I didn't know, that his resume was actually, where is it? Where's his resume? Give me 1 second. Right, so his resume is actually a shared library. And I stored it in documents martinresume.pdf. So then, bad actor on this Ubuntu host replaced the MySQL server and starts this rogue server. And this rogue server have the configuration option to push the resume PDF, start on this port, and then I need to know the plugin name. So let's start it. All right, that started. And now here, back to my workstation, I have a pretty old workbench here. 8013. And I have this configuration, my hack database, and I'll try to open it. Here we go. So calculator. That means that, thank you. It actually gives me the error because this plugin is fake one. It's not the real plugin. If I want to disguise it, I will create the real plugin, which will pass this and it will say it cannot connect, or I can even make it connect to me, right? But we have successfully executed the code on the client workstation. All right, so let's get back to the presentation. All right, so this is just the recording. I put the recording in the slides, the same thing. that I did, just in case. Right, so let's go to Windows. So the same thing applies to Windows. It actually has the ability to load library using the load library call. So Martin has recorded this for Windows. This is a DLL code. And the DLL code will do the message box to demonstrate that this code has been executed. So let's see, let's start that recording for Windows. So we have a message box here, shared library. We compile the shared library. We have it here as DLL. I'll explain that later on. So we have this DLL, Amber DLL. And then this is an old, again, the old Workbench, 0.18 before the patch. Patch is 8.0.19. And then we connect to the database, right, the host port. And there's nothing in advanced here. It's just out of the box. And then we connect. And here we go. So it has executed the code. And we can see that from the process list that the Amber DLL has been loaded. Now, what is interesting about the Windows is load library is different. We will not be able, in the default settings, will not be able to do the override for the path. So it will always append the DLL. We cannot go beyond the 512 bytes because the hard-coded length for the library is less. So Martin will talk about that a little bit more. All right. So now that was fixed. And now in February 2023, we discovered a new security issue, a bypass to this code. And Martin discovered that, and he will talk about that now.
Hello, everyone. So yeah, like Alex said, there is a twist to this story. It turns out we can actually bypass the patch which Oracle provided with their own fix to the original issue. So basically what we can do, we can append an extended setting called character set and use a non-default setting for this to be a 2-byte character set. Instead of UTF-8, we can use UTF-16, for example. In that case, let's see what's going to happen. So this is the code we have seen before. The patch Oracle did, they did a lookup function, myStrCSPN, and they look for function directory separator, which is a / on Unix-like systems, and is a / on Windows, and also a / on Windows as well, because in Windows they support both. So what we're trying to do is to check if path we control contains this directory separator, and if it contains it, we just error and exit from client code here. But take a look at this first parameter. It's a character set. If we use a 2-byte character set, and actual value of this is a single byte ASCII string, what's going to happen? Any guesses? Yeah, I'll just skip and say it's okay, it's fine. So we just bypass this validation. So the trick is simple, and here this is this is how it works. So in a Workbench, we can go to the advanced and specify op character set to be UTF-16. And also we can specify location of plugin dir. But for this attack, it's not important. The important thing is to be able to set the non-default setting for the character set. Yep. So this is on a Workbench 8030, which is patched by original Oracle fix. And now let's take a look at the Windows part. Sure, it's not playing. Which one? Oh, yep, thank you. So let's take a look at the Windows part. This is another attempt of this character set exploit. So we have another version of our library called Amber2. And now let's take a look at the MySQL client version. It's going to be version 32, which is previous to current one released a few days ago. And let's try to run it. It will reject with null path allowed until we supply the character set trick. So let's rerun this with a character set to be UTF-16 to byte character set and see what happens. There you go. That was fixed just a few days ago in April CPU. Back to you, Alex.
Thank you, Martin. Great find. So let me go back to what we did. I skipped that part. So in February 2023, we discovered this bypass. We reported to Oracle MySQL team. And just a couple days ago, April 18th, the issue was fixed. So now it's fixed in MySQL 8033 and 5742. So it has been assigned this CVE. And you can also look at the commit. And this commit went into the release notes. There has some information here. Lots of information, what has been fixed. You can examine the commit as well. So that has been actually fixed in the latest versions of MySQL. And we can actually verify that it has been fixed. So here we, let me start that. It didn't start. All right. So we use this version. Unfortunately, it doesn't show very well. But this is the latest version, 8033. So then I connect to my host. It says, again, no paths allowed. Now we supply this character set, and let's see what happens. Same setup as Martin was demonstrated. Right, so now it says that the UTF-16 character set is not supported. So basically what happened, UTF-16 character set was not fully supported in the client, and especially in the auth phase. So they just disallow it. All right. So this is our attack successfully demonstrated. So we wrote a rogue server with the ability to push the plugin dir. It's a fake server in Python. We have, because of the buffer overflow, we were able to load an arbitrary file. For example, a PDF file that someone sent you via LinkedIn, and you just saved it. We demonstrated how this works on the pushing the arbitrary code with init in it. So versions affected. 2019 issue, all the versions of MySQL, MariaDB, server. Again, I'm saying server here, but this is actually the client. The client code is part of the server. So any version that released earlier than October, November 2019 is probably affected. 2023 issue with UTF-16 bypass was just fixed. 8.0 only MySQL and Percona server is affected. MariaDB is not affected. MariaDB just used the sanitization on the plugin name right away. Fix is just released April 2023. It is in Oracle CPU release if you receive those. So what's the client? Which clients are affected? Pretty much any client that is based on lib MySQL C or C++. It is original lib MySQL C version. It's a connected C++ or DBC driver also based on the lib MySQL. Pretty much any driver, any client based on lib MySQL. For the GUI tools, MySQL Workbench, Navicat, SQL Pro, all the versions probably affected. So if you're using all the versions, just upgrade. Or just don't connect to MySQL server, even your own MySQL server from the client workstation. Right? GDBC or native implementation is not affected by this one. They implemented a completely different code. All right, so summary and conclusions. Rogue server can attack client. Don't connect to the server if you suspect that the server has been hacked. And the common question here is that, can it be man in the middle? Potentially, yes, it can be man in the middle. But if it's man in the middle, then SSL will protect us, sort of. If it's hacked server, the attacker gets control to the server, so SSL is useless. It's the same server. You can use the same certificate. A remote code execution on client machine. It's sort of difficult to exploit vulnerability. You need to use this social engineering to push the resume. You need to know what the path is. Now, the original issue was fixed in 2019. The new issue only applies to MySQL Percona server and just recently fixed. And finally, multi-byte unsafe string comparison is dangerous. If you have a function from 1982 or 1984 in your code base, test it against the multi-byte check sets, right? Because no one thought about that back then. All right, and I think that's it. Finished 10 minutes early. Any questions? Thank you.
Thank you, Alexander and Martin. This was really interesting. I think this issue might be even more potent than was shown here, right? A lot of clients use these libraries, and those clients might facilitate distributing or writing files on disk, stuff like that. And it's going to take years and years for all those clients to update those libraries, right? This is going to hunt us for years. I'm sure there must be some interesting questions from the room. Anybody? Okay. Not directly. Yeah, I don't have really questions. There was a lot of information in the talk. Maybe one interesting question. Would it also be possible to use UNC pods to load libraries on Windows? Did you look into that a bit? Loading DLLs from other servers?
Yeah, we've thought about that. The thing is that we don't control the beginning of the string, because the beginning of the string is the plugin dir. And on Windows, it all starts with whatever its default C, comma. Right, Martin? Is it correct? So on Windows, we cannot control the beginning because we cannot control the beginning of the string, and the overflow only affects the end of the string because how it reads the characters. We cannot push the / and something.
Yeah. And so this path is defined in an environment variable, or where's this path, the beginning of that string? Is that, or is it in the ini file, defined in the ini file, or in?
MySQL has this plugin dir.
Yeah.
And the plugin dir defines the path. So if we have the ability to, on the client side, to control the plugin dir, then we can push that like that. But it's unlikely. If you control the plugin, if you control the ini file on the client side, then you pretty much control the client. You can load whatever you want. You can execute the command directly. You don't have to do that. So it is more difficult. There are lots of interesting possibilities here, though. But not what we tried some of them, and we haven't found it.
Yeah, I think the vulnerable library used in other clients might open up other doors. And
that's right.
I want to thank you, Alexander and Martin, for this great talk about how a MySQL server can hack you.